Hello everyone. Welcome back to my YouTube channel. Today we will discuss important questions based on heat transfer operations. If you like my video, please like, share, comments, and subscribe to my YouTube channel, which is Chemical Edda. Now, let's see the questions. So, the first question is, define heat transfer. So, heat transfer is deal with the rates of exchange of heat between hot and cold bodies, called the source and receiver. Hence, as we know, when two objects at different temperatures are brought into thermal contact, heat flows from the object at the higher temperature, which is called a source, and to that at the lower temperature, which is called a receiver. So, in heat transfer, we study how to calculate rate of heat transfer and how temperature change with respect to time between hot source and cold receiver. Hence we can say that in heat transfer, the temperature difference is the driving force, and the net flow is always in the direction of the temperature decrease. Now, next question. Define heat. So, heat is defined as a form of energy which is in transit between a hot source and a cold receiver. Hence, the transfer of heat mainly depends upon the temperatures of the two bodies, or substances, or parts of a system. Now, next question. What is the need for the study of heat transfer? The study of heat transfer is carried out for the following purposes. First is to find the rate of flow of energy as heat through the boundary of a system under a steady and unsteady state. Another purpose is to predict the temperature of the system as a function of time under steady and transient conditions. Now, next question. What is the difference between heat transfer and thermodynamics? Difference between heat transfer and thermodynamics is the study of the rates of exchange of heat between hot and cold bodies, called the source and receiver, is called heat transfer. And the study of the flow of heat, or any other form of energy, into or out of a system, as it undergoes a physical or chemical transformation, is called thermodynamics. In heat transfer, we find out the rate of heat transfer during a process or from a hot source to a cold receiver. And in thermodynamics, we find out the heat interaction during a process or from one initial point to the final point. In heat transfer, we find out heat transfer per unit time. And in thermodynamics, we find the amount of heat transfer during a process and have nothing to do with the time required for that heat transfer to occur. In heat transfer, we calculate heat interaction joules per second. That is what? In thermodynamics, we calculate heat interaction in joules. Example: when steel bar kept in hot water, so heat transfer may be used to predict the temperature of both the bar and water is a function of time. And for this example, thermodynamics may be used to predict the final equilibrium temperature of the steel bar and water system. However, it does not help us to find out what is the temperature of the bar and water after a certain time, before equilibrium reached. Now, next question. What is the difference between heat transfer and mass transfer? So, the difference between heat transfer and mass transfer is: heat transfer is defined as the process in which heat is transferred from hot and cold bodies, called source and receiver, due to temperature difference. The process of transfer of mass, as a result of the concentration difference of a component in a mixture or two phases in contact, is called mass transfer. Heat transfer operations depend on the temperature difference of two bodies, of substances, or parts of a system. And mass transfer operations depend on molecules diffusing from one distinct phase to another, and are based on differences in vapor pressure, solubility, or diffusivity. Heat transfer deals with the determination of rates of heat transfer, and mass transfer deals with the determination of rates of mass transfer. The modes or mechanisms by which heat transfer may occur: conduction, convection, and radiation. And the modes or mechanisms by which mass transfer may occur: molecular diffusion and turbulent or eddy diffusion. Heat transfer occurs in heating, cooling, phase change, evaporation, drying, distillation. And mass transfer operations occur in separation techniques like distillation, gas absorption, drying, extraction, crystallization. Now, next question. What are the modes of heat transfer? So, there are three modes of heat transfer: conduction, convection, and radiation. In this figure, we can see the bottom surface of the pan gets heated when it is kept on the burner, because heat energy from fire is transmitted in the form of electromagnetic radiation to the bottom surface of pan. Hence the bottom surface of pan gets heated due to the radiation mode of heat transfer. Then, the fluid in the pan gets heated, because heat transfer through the fluid, which is caused by molecular motion, due to density difference, as the bottom surface of the pan is hot. This is due to the convection mode of heat transfer. Now, if the handle of the pan is a good conductor of heat, and when we touch handle, our hand gets burned, because heat is transferred from pan to handle and from one end of the handle to another end. This is due to the conduction mode of heat transfer. Now, next question. What is conduction? So, conduction is the mode of heat transfer in which heat is transferred from one part of a body to another part of the same body, or from one body to another, which is in physical contact with it, without appreciable displacement of particles of a body. In conduction, heat transfer occurs without the actual migration of particles of the medium from a region of higher temperature to a region of lower temperature. Conduction mostly occurs in solids. Examples: heat flow through the brick wall of a furnace, the metal sheet of a boiler, and the metal wall of a heat exchanger tube. Now, next question. What is convection? Convection is the mode of heat transfer in which heat is transferred from one point to another point within a fluid, that is gas or liquid, by mixing of hot and cold portions of the fluid. Hence, in convection, heat transfer occurs due to movement of the fluid on a macroscopic scale in the form of circulating currents. The circulating currents may be arise either by heat transfer process itself or some external agency. Hence, it is attributed to the macroscopic motion of the fluid. Convection is restricted to the flow of heat in fluids. Examples: heating of room using a steam radiator, heating of water in cooking pans, heat flow to a fluid pumped through a heated pipe. Now, next question. What are the types of convection? There are two types of convection. First is natural convection. In natural convection, the fluid motion results from the difference in densities of the warmer and cooler fluid, arising from the temperature difference in the fluid mass. Second type of convection is forced convection. In forced convection, the fluid motion is produced by mechanical means such as an agitator, a fan, or a pump. Now, next question. What is the difference between natural and forced convection? The mode of heat transfer in which the circulating currents arise from the heat transfer process itself is called natural or free convection. And the mode of heat transfer in which the circulating currents are produced by an external agency is called forced convection. In natural convection, the circulating currents are generated as a result of change in density of fluid when it is heated. And in forced convection, the circulating currents are generated as a result of external source, such as agitator in a reaction vessel, pump, fan or blower. No external force is required for heat transfer in natural convection. And only external factor can cause heat transfer in forced convection. Example of natural convection is Heating of a vessel containing liquid by means of a gas flame situated underneath. Example of forced convection is heat flow to a fluid pumped through a heated pipe. Now, next question. What is radiation? So, radiation is a mode of heat transfer, in which heat is transferred from one body to another through space, not in contact with it, by electromagnetic waves. Hence radiation can occur, even in a vacuum, and no material medium is required for heat flow by radiation. Examples of radiation are the transfer of heat from the sun to the earth, and the loss of heat from an inlaid steam pipe to the ambient air. Now, next question. What is the difference between conduction and convection? The difference between conduction and convection is conduction is a process in which the transfer of heat takes place between one part of a body to another part of the same body, or between objects which is in physical contact. And convection refers to the form of heat transfer in which energy transition occurs within the fluid by mixing of hot and cold portions of the fluid. Conduction occurs due to temperature differences, and convection occurs due to density differences. In conduction, there is no appreciable displacement of particles of a body occur. And in convection, it is attributed to the macroscopic motion of a fluid. Conduction occurs only in solids, and convection occurs in liquids and gas, that is fluids. Conduction is a relatively slow process, and convection is faster than conduction. Examples of conduction are heat flow through the brick wall of a furnace, the metal sheet of a boiler, and the metal wall of a heat exchanger tube. And examples of convection are heating of room using a steam radiator, heating of water in cooking pans, heat flow to a fluid pumped through a heated pipe. Now, next question. What is the difference between conduction and radiation? Conduction is a process in which the transfer of heat takes place between one part of a body to another part of the same body, or between objects which is in physical contact. And radiation is a process in which the transfer of heat takes place from one body to another through space, not in contact with it, by electromagnetic waves. In conduction, heat travels from a high temperature area to a low temperature area, which is in direct contact. And in radiation, heat flows through empty spaces. Conduction occurs only in solids, and radiation occurs in all objects of solids, liquids, and gas at a temperature above or at absolute temperature. In conduction, law of reflection and refraction does not follow. And in radiation, law of reflection and refraction follow. Conduction is a relatively slow process, and radiation is the fastest way of heat transfer. Examples of conduction are heat flow through the brick wall of a furnace, the metal wall of a heat exchanger tube. Examples of radiation are the transfer of heat from the sun to the earth, the loss of heat from an inlagged steam pipe to the ambient air. Now, next question. What is the difference between convection and radiation? The difference between convection and radiation is: convection refers to the form of heat transfer in which energy transition occurs within the fluid by mixing of hot and cold portions of the fluid. And radiation is a process in which the transfer of heat takes place from one body to another through space, not in contact with it, by electromagnetic waves. In convection, heat is transferred by the flow of the fluids. And in radiation, heat is transferred through the radiation emitted by bodies without the need for a medium. Convection occurs in liquids and gas, that is, fluids. And radiation occurs in all objects of solids, liquids, and gas, at a temperature above or at absolute temperature. In convection, law of reflection and refraction does not follow. And in radiation, law of reflection and refraction follow. Convection is faster than conduction, but slower than radiation. And radiation is the fastest way of heat transfer. Examples of convection are heating of room using a steam radiator, heating of water in cooking pans, heat flow to a fluid pumped through a heated pipe. Examples of radiation are the transfer of heat from the sun to the earth, the loss of heat from an inlagged steam pipe to the ambient air. So that's all about important questions on heat transfer operations. These are basic questions. In the next video, we will discuss another questions. If you like my video, please like my video, share this video with your friends, and subscribe to my YouTube channel.